Hi, welcome to the channel. Here I post challenging math problem video daily. If you like this video, then give it a thumbs up and subscribe to the channel. So without further delay, let's start. So today we have a problem based on ellipse, which says let d be the perpendicular distance from the center of the ellipse x square by a square plus y square by b square equal to 1 to the tangent drawn at a point P on the ellipse. And if f1 and f2 be the foci of the ellipse, then pf1 minus pf2 whole square equal to k a square into 1 minus b square by d square, where k is 4 options are given. So what can we do? We just write p in terms of its uh, that parametric form. Okay, so p can be written as a cos theta and b sin theta. Okay, now again AE is a sorry, f1 is a comma 0 and f2 is minus a comma 0. So the tangent at point P, so we write this expression. Okay, so this is the equation of the ellipse. So we write the tangent at this point as we know as x cos theta by a plus y sin theta by b equal to what? Okay, so from this origin we drop a perpendicular on this tangent, so this t can be written as uh, okay, this is minus ab. Okay, let me do one thing, just let's simplify this equation a little bit. So we can write this as a bx cos theta plus ay sin theta minus ab equal to 0. So t can be written as distance from the perpendicular. So this is minus ab, putting x and y as 0, and this is under root a square plus b square, means uh, b square cos square theta plus a square sin square theta. Okay, so this is d. So we just do one thing, we take this mod sign as positive because this ab is negative, and this sine square theta we can write it in terms of cos square theta. So this is b square cos square theta, and this is a square minus a square cos square theta. Okay, now this is ab divided by, we take cos square theta common, so we can write this as a square plus b square minus a square cos square theta. Okay, so now we know that e equal to under root 1 minus b square by a square. So this a e equal to this a square minus b square and a square is square. Okay, so if we substitute this value as uh, in terms of e, so we can write this as a square, and this is taking minus common, so we can write a square is square cos square theta. Okay, now taking again this a square common and take out this a square, so we can write this ab by a under root 1 minus e square cos square theta. Okay, so this a will get cancelled, so the d is b by 1 minus e square cos square theta. So this is d. So we uh, square the both sides, so we can write this d as b square by 1 minus e square cos square theta. Okay, so this is equation number 1. uh, okay, b square by d square, so we can write this in terms of b square by d square, that we will do it later on. Okay, now this left hand side is pf1 minus pf2. So what we can write pf1 minus pf2 as let's draw the once again, this is the, just a minute, this is the ellipse. So this is f1, this is f2. Okay, this is p point. So we can write it in terms of that directrix. Okay, so pf1 can be written as e into pm. Okay, so pm means this e into, this is total distance is uh, this p, this is o, so om minus, so this is om minus o, say suppose this is n. So e into pm can be written as om minus on. So e, om is the equation of the directrix. So this is a by e minus, and on is the a cos theta. Okay, so if we multiply this, so we can write this as a minus ae cos theta. So similarly pf2 can be written as the other side, so a plus ae cos theta. Okay, so this p of f1 minus p of f2 is, this thing will get cancelled, so we can write this as 2ae cos theta. We take the mod sign because we have to take the square itself, so no problem with that. So now just write pf1 minus pf2 whole square equal to, this is 4 a square e square cos square theta. And now this a square e square cos square theta we can write in terms of 1. So just solve this equation. So we can write this as 4, this is a square, and e square cos square theta means this will go that side. So 1 minus b square by d square. So this is 1 minus b square by d square. Now this is given as k, so k equal to 4. Okay, the option to this question is option C. Okay, so this is all for today. See you tomorrow.